So I'm Shalev.
I'm Boettcher.
Thank you. This is our guided tour in our poster, Temporal Regularities Guide Spatial Attention in Young Children.
Yeah, so before we talk about kids, it's important to just talk about spatial attention. And we know a lot about guidance of spatial attention in static displays, but we know a lot less in dynamic displays. And in the real world, things are often dynamic. So that's our interest here. And we know from last year, Nir presented a talk at V-VSS about temporal regularities and how they can actually be used to guide spatial attention.
But moving on to children this year, we're going to look at two complementary aspects of cognition in childhood. Children are not very good at searching,
but they are highly efficient learners, which fits quite well with our task because it involves both searching and learning regularities.
So that will be our main research question. We're going to ask whether children can utilize task-embedded informative regularities to guide spatial attention.
Yeah, so for the task itself, all you need to know before you see it is that you're searching for airplanes and ignoring bugs and birds. And what you'll see here is 4 spatial quadrants that are a bit cloudy, and the targets and distractors kind of slowly appear and disappear within the display. So in one single trial, you're searching for 8 airplanes or 8 targets, and you're trying to ignore the distractors. So some things to point out is that the number of targets is 8 that you're searching for throughout the trial, and the number of distractors is constantly changing.
And perhaps the critical experimental manipulation here is that 4 targets always appeared at the same time and spatial quadrant throughout the experiment. So they were entirely predictable as to where to look. For example, there was always a target that appeared after 3 seconds, for example, for participant A at the upper right corner of the screen. And we tested 80 kids and 25 adults.
Yes.
And
Yeah, and overall, our main questions are looking at the group differences between the kids and the adults for search performance, and then also looking at differences between these predictable and unpredictable targets. So here, we'll start with the hits. So you have % hit, and you can just see that there's a main effect where adults are better at finding these targets compared to kids.
Yes, but the other aspect of performance here is that actually both groups were capable of using these regularities to enhance performance. So there was a main effect of target predictability and no group interaction there. And another thing that Sage mentioned was the number of distractors that varied throughout the experiment.
Yeah, and what we can do here is split the same data up by the number of distractors, as Nir said, and on the x-axis you can see as the number of distractors is going up, overall performance is going down, but this is a much stronger effect in kids compared to adults. So the kids suffer more from more distractors. But overall, you can also quite clearly see here that the children show this prediction benefit basically all the way through.
Yeah, so another perspective we try to take here is to look at the group of children and characterize individual differences within that group. So we had 2 continuous measurements. One is age. So within the group of 5 to 6-year-olds, we could look at individual differences related to age in months. And another thing we did was asking teachers to report symptoms of ADHD to mark individual differences in attention skills using the SWAN questionnaire.
Yeah, so if we look at age on the x-axis within that 12-month period, you can see there's a significant correlation with false alarms. So the older kids are false alarming less.
Yes, just something complementary. Older children are actually finding more targets.
Yeah, but if we break this down by this prediction benefit, so we take the predictable trials and subtract the random trials, we see that there's no difference with age. So this doesn't correlate. So you're basically showed the same strong prediction benefit all the way through.
Yeah, and we could take the same prediction benefit marker and look how it changes with individual differences in attention skills, and we found a positive correlation and confirmed this correlation also when adding the SWAN score as a covariate in a linear mixed effects modeling. And the same SWAN questionnaire did not interact or correlate with hit rate or false alarms. So Sage, why don't you start with conclusions?
Yeah, so the first set of conclusions, one thing to point out is that kids were worse than adults at this task, so they found fewer targets overall. They were also more affected by spatial competition, so the distractors showed a stronger slope than the adults, so the kids showed a stronger slope, but they all quite comparable with the adults when it comes to using these predictions, actually.
Yes, and when we looked at the group of children, we noticed that the age difference actually correlated with performance, and differences in attention skills correlated with predictions. Let's just say thank yous.
Yes, thank you. So we want to thank Hannah Wilkinson, who was the bachelor student who basically did all the work here, collected all the data, helped us come up with the ideas, and was really fun to work with. Gaia Sharif, who's the head of the developmental lab here at Oxford, and our supervisor, Kia Nobre.
Yes, and thank you. Thank you for coming.
Yeah.
Bye.